Hello friends, today we take short example of second chapter linear correlation, section D, example number 11. The following information is obtained for 9 pairs of observation. Sigma x is equal to 51, sigma y 72, sigma x square 315, sigma y square 582, sigma xy 408. Find the correlation coefficient. So in this example 9 pairs is given. So the value of n is equal to 9. Now remaining all the values is given here. So just we have to put in the value in the formula. So R is equal to n sigma xy minus sigma x into sigma y upon under root n sigma x square minus sigma x whole square into under root n sigma y square minus sigma y whole square. Now 9 pairs given, so n is equal to 9. Sigma xy is given here 408. Sigma x is given 51. Sigma y is given 72. Now the value of n is equal to 9. Sigma x square is given 315. Sigma x 51 square. N is equal to 9. Sigma y square is given 582. And sigma y, that is 72 whole square. So 9 into 408 become 3672. 51 multiplied by 72, that is also 3672. 9 into 315, that is 2835. 51 square, that is 2601. 9 into 582, that is 5238. 72 square, that is 5184. Here 0. 2835 minus 2608, so 234. 5238 minus 5184 become 54. 0. 234 into 54 become 12636. 12636 make root, that is 112.41, and 0 divided by 112.41, so answer is 0. Correlation coefficient between two variables is 0. Now section D, example number 12. The information obtained on the basis of ranks given by two judges to 8 contestants of a dance competition is given below. Sigma Rx minus Ry square, that is 126, where Rx and Ry is the rank given by two judges. So here very simple example. Here 8 contestants participating in a dance competition. So n is equal to 8. Now 2 judges given the rank. So first judge rank is Rx, second judge rank that is Ry, and we all know that Rx minus Ry become D. So sigma D square is given 126. So this is the value of sigma D square, 126. And we have to find Spearman's rank correlation coefficient. So R is equal to 1 minus 6 sigma D square upon n square minus 1. So 1 minus 6 sigma D square is 126. Number of contestants that is 8. 8 square 64 minus 1. So 6 into 126, that is 756. 64 minus 1 becomes 63 into 8 become 504. And 756 divided by 504, that is 1.5. And 1 minus 1.5 become minus 0.5. So the rank correlation coefficient between two variables is minus 0.5. Now section D, example number 13. The rank given by two experts on the basis of interviews of 5 candidates for a job are 3, 5, 5, 4, 1, 2, 2, 3, 4, 1. Find the rank correlation coefficient from this data. So here 5 candidates is given. So first we take candidates. 5 is A, B, C, D and E. Now 2 experts given rank on the basis of their performance. So rank given by first expert. We take as a Rx. Now rank given by second expert. That is Ry. Now rank given by two expert is given 3, 5. So first expert given 3, second expert 5. Second 5, 4. Third 1, 2, 2, 3 and 4, 1. So here Rx and Ry is given. So first we find different Rx minus Ry. So D is equal to Rx minus Ry, 3 minus 5 minus 2, 5 minus 4, 1, 1 minus 2 minus 1, 2 minus 3 minus 1, 4 minus 1, 3. Now total of D is always 0. Now D square minus 2 square 4, 1 square 1, minus 1 square 1, 1, 3 square 9. Now total of sigma D square 9 plus 1, 10, 11, 12 and 16. And here we have to find rank correlation coefficient. So the formula of rank correlation coefficient, R is equal to 1 minus 6 sigma D square upon n square minus 1, 6 sigma D square 16 We have 5 candidate. 5 square 25 minus 1. 16 into 6 become 96. 25 minus 1 24 divided by 5, that is 120. R is equal to 1. 96 divided by 120, that is 0.8. And 1 minus 0.8 become 0.2. So the rank correlation coefficient between two variables is 0.2. Now we take long example from section F. Example number 9. Two following data is obtained for two variables, inflation and interest. So inflation is given as a x and interest rate as a y. N is equal to 50, sigma x 500, sigma y 300, sigma x square 5450, sigma y square 2000, sigma x y 3090. Later on, it was found that one pair of observation 10-6 was included additionally by mistake. Find the correlation coefficient by excluding this pair of observation. So in this example we have two variables. One is inflation as a x, interest rate as a y. Total 50 observation. But later on it was found that one pair is taken additionally by mistake. So here 10-6 means 10 as a x and 6 as a y. Find the correlation coefficient by excluding this pair of observations. So this pair is taken wrongly, so we have to exclude from this observation. So here n is equal to 50. One pair is wrongly taken, so 50 minus 1, that is 49. Sigma x 500, but x taken wrongly as a 10, so 500 minus 10 become 490. Sigma y is given 300, but y is taken wrongly 6, so 300 minus 6 become 294. Sigma x square 5450, x is taken wrongly, so 10 square 100. So 5450 minus 100 become 5350. Sigma y square is given 2000 and y is taken wrongly 6 square. So 6 square become 36. So 2000 minus 36 become 1964. And sigma xy means x into y. So 10 into 660. So 3090 minus 60 become 3030. So out of 50 observations, one pair wrongly, so deduct, so 49. Sigma x 500 minus wrongly x taken 10 minus 490. Sigma y 300, y wrongly taken 6, so 294. Sigma x square 5450, x is wrongly taken 10, so x square, so 10 square 100. 5450 minus 100 become 5350. Sigma y square 2000, y is taken 6 as a long, so 6 square 36, so 1964. Sigma x square 3090, so xy means x into y, 10 into 660, so 3030. Now I am applied the formula, so concentrate here. The main formula, that is R is equal to, I am taking here, R is equal to n sigma xy minus sigma x into sigma y upon under root n sigma x square minus sigma x whole square into n sigma y square minus sigma y whole square. N is equal to 49. Sigma xy, that is 3030. Sigma x 490. Sigma y as a 294. N as a 49. Sigma x square 5350. Sigma x 490 whole square. N 49. Sigma y square 1964. Sigma y 294 whole square. So 49 into 3030, that is 1,48,470. Now 490 into 294, that is 1,44,060. 49 into 5,350, that is 2,62,150. 490 square, that is 2,40,100. 49 into 1,964, so 96,236. 294 square, 86,436. So minus this two value, 1,48,470 minus 1,44,060. That is 4,410. Now 2,62,150 minus 2,40,100. That is 22,015. 96,236 minus 86,436. That is 9,800. 4,410. Now multiply between these two variables. That is now making root of this variable 4,410 upon 14,700. So 4,410 upon 14,700, that is 0.3. So this is long example and useful for the board examination. 50 observation is given. One pair means x and y is taken wrongly. So 50 minus 1 pair 49. Out of sigma x 500 minus wrong x 10, so 490. Sigma y 300, y is taken 6 as a long, so 294. Sigma x square 5450 minus x 10 square 5350. Sigma y square 2000 minus 6 square 36 1964. Sigma x square 3090 minus xy means x into y 10 into 6 60 3030. Then we applied the formula here. So the answer is 0.3. So the correlation coefficient between two variables is 0.3. So today we completed our second chapter, linear correlation, and this chapter having weightage in board examination, that is 12 mark. And I hope you will like this lecture and make maximum practice for board examination.